Okay, this is 8G7, 8th grade geometry, standard 7, video 1, the Pythagorean theorem and its missing lengths. In the previous lesson, we talked about the proof of the Pythagorean theorem and its converse, and today we are going to start solving this theorem and trying to find the missing lengths of the legs of the right triangles. All right, a few terms to know. I'd like you to write these down in your journal and define them. All right, there is the theorem a squared plus b squared is equal to c squared. And what I've done here is I've taken 3 screens, all with the same numbers, just to keep it consistent. And I'm going to be solving for each of the missing legs. So in this particular example, they give us A, they give us B, and we are missing the hypotenuse, which is length C. So this is basic substitution. We're going to take the numbers that they give us, substitute them into the formula where they belong, and then solve for the missing variable. All right, so they give us A. A is 3. We are to square it and add it to B, which they give us, and square it, and that should be equal to the missing length, which is the hypotenuse squared. All right, solving down the line, 3 squared is 3 times 3, which is 9, 4 times 4, which is 16, and that should be equal to c squared. 9 plus 16 is equal to 25. 25 is equal to the hypotenuse squared, and we don't want c squared, we want just 1c. So the inverse operation of squaring a number is taking its square root. So to undo the square of c, we square root c squared, and then if we do that to the right side, we must also balance it out and do that to the left side. So c squared, the root of that would be just 1c. The square root of 25 would just be one of those 5s, and we're only dealing with the positive root because we are dealing with the length of a leg, and lengths cannot be negative. So the length of the hypotenuse is 5 centimeters. Okay, the next screen is going to look very similar, except you're going to notice that I've changed the question mark, which is going to change the process here down the road. I'm just going to take the numbers that they give us and substitute it into the formula where they all belong. All right, so A is 3, and we square it, plus B is a question mark, so I don't know what B is right now, but we square it, and that should be equal to C, which is 5, and we square it. All right, solving down the line here, 3 squared is 9, plus B squared is equal to 5 squared, which is 25. And now this is our solving one-step equation. For right now, the one step is going to be getting this 9 over to the other side of our wall. And in order to do that, we are going to subtract 9 from both sides. So B squared is going to be equal to 25 minus 9, and that would be 16. And we don't want, as we said in the last screen, we don't want to know B squared. We would like to know what B is, 1B. So we take the square roots of both sides, and B would be equal to 4. And we knew that. We knew that from the previous screen because they gave that to us. So B is equal to 4 centimeters when A is 3 centimeters and C is 5 centimeters. All right, this is going to look very familiar. I did not change up the screen at all. I'm just changing the missing variables or the missing legs that they give us. Okay, so in this one, the A is missing, so I'm going to square it, plus the 4 squared is equal to now our 5 squared. A squared we don't know. b squared is 16 and c squared is 25. Solving the equation, here's our wall coming straight down. If I'm solving for a squared, I need to get rid of this plus 16, and the opposite of that would be to subtract 16. So I'll do that one horizontally. Last time I did it vertically, so we have a squared plus 16. We are to subtract 16, and that is equal to 25, and we are also to subtract 16. That is nothing new. We've been doing that for a while now. All right, so what are we left with? Well, since we did it horizontally this time, we have a squared is equal to, what's 25 minus 16? 9. And to undo a squared equal to 9, we need to take the square root of both sides. So a is equal to positive 3, and look at how all of that worked out. Every time we did the problem for that missing variable, we always ended up with that 3, 4, 5 right triangle. And again, this only works with right triangles, 90-degree triangles. All right, in the directions here it says find the unknown length, and if necessary, use a calculator. Yes, I said that. You can use a calculator this time to round to the nearest hundredth. All right, so they didn't give me the numbers here, but they gave me a piece of grid paper, and I can count the units for my A and my B, and I can use those unit boxes to help determine what my hypotenuse is. All right, so let's do that first. The A length has 1, 2, 3, 4, 5 units. We'll call it units because it didn't tell me inches, centimeters, etc. So 5 units is 5u. And my B length is 1, 2, 3, 4 units. So my B is 4u. And since this is a 90-degree right triangle, let me draw that in for you, I can determine the hypotenuse, that slanted leg, by using the theorem. All right, so a squared is 5 squared, b squared is 4 squared, and that should be equal to c squared. 25 plus 16 is equal to c squared, and then 25 plus 16 is 41, and 41 is equal to c squared. So we have to take the square root of both sides to get c. So c is still equal to this square root of 41 because that is not on our perfect square chart. So it's time to take out the calculator. We've also worked with approximating square roots, but I think we're going to use the calculator and round to the nearest hundredth because that's what the directions said. So let's take this out. My calculator is a little different from yours. So I just have this SQRT button. I can show you in class how to use your calculator. So let's just do 41, and the square root of that says 6 and a decimal 403124. All right, so I know that my answer is going to be 6 points, and I need the hundredth position, so that would be 2 positions after the decimal. So the third number is actually going to tell me what to do to the 0. So 6.4 blank. Well, the 3 is between what? It's less than 5, so we're going to keep that 0 the same. So we're going to end up at 6.40. All right, so if I were to come over to my triangle, C is 6 and 40 hundredths units, because they didn't tell us. what unit of measurement we're using. And I'd also like you to take a look at this and see that the hypotenuse is the longest leg. It's always the longest. So we had a 4 unit, a 5 unit, and a little bit over a 6 unit here. Okay, the last one is that real world example that they always speak of here in the standard. And I'm not the greatest artist. I actually had a student draw this picture for me. And it is representing the side of a building. Here's a little green bush and some grass that's grown, and a ladder that we're trying to get up to the top of this building. So they give us some information, and we're going to write that in. It says a ladder that is 15 feet long. So how long is the ladder? Well, the ladder is 15 feet long, and it's placed against the wall. Well, the wall is right here. Okay, so it's placed against the wall. And I know that the bottom of the ladder is 5 feet from the wall. Well, if this is the bottom of the ladder and this is the wall, I know that this length right here has to be 5 feet. All right, so it says to the nearest foot, so that is rounding to the nearest whole number foot. How far up the wall does the ladder reach? So the missing value right now is the height of this wall. All right, so think of the letters that we're using from the theorem, A, B, and C. Who do we know? Well, we know that this slanted line right here, the ladder, has to be the hypotenuse because it is directly across from the 90-degree angle. So here's your 90-degree angle down here in the corner, and directly across from it is your hypotenuse. That never changes. So that means the missing length is either your A or your B, and those are interchangeable. So let's just call that B. How about we call that B today? So this is A. All right, so now we use our theorem. The theorem states A squared plus B squared is equal to C squared. And let's substitute in our numbers and solve. All right, so A is 5 feet, and we square it. B is missing, and C is known as 15 feet, and we square it. 5 squared is 25. Missing variable. 15 squared is 225. All right, we have the wall coming straight down. We need to solve for the missing variable. So if I have a 25 on the left, I need to get rid of it. So we'll subtract 25 from both sides. And we are left with B squared equaling 200. We subtracted those. All right, now I don't want B squared. I would like to have B. So to undo the square, we would have to root both sides. So B is equal to, and here we go again, 200 is not a perfect square, and I need to round that to the nearest foot. You could use your approximation skills that we learned earlier in the year, but in this case, we talked about using a calculator. All right, so if I type in 200 and we take the root of it, it says to the nearest foot. Okay, so if we need the nearest foot, we round 14.14 to 14. All right, because this 1 to the right of the decimal, the 1 tells me to keep the 4 the same. All right, now does that match our idea that the hypotenuse is the longest leg? Okay, let's check it. A is 5, B is 14 approximately. I don't even want to call it equal to. We'll say that B is approximately 14 feet. And then there it is. The hypotenuse is still the longest leg at 15 feet. Okay, in your journal, Please define the given terms on page 2 of the flip chart. Write a few sentences on what you've learned from this video, and think about the standard today. The standard says we're going to be solving for missing legs of a right triangle using the Pythagorean theorem, and that will pretty much wrap it up in terms of the theorem. Coming to a theater near you is going to be using it to find the distance between 2 points, and that's going to be coming up in our next video. See you in class.